Hello students, so today we will start your first chapter of mathematics, that is rational and irrational numbers. Okay, so your syllabus is basically divided in 20 chapters. The first chapter is rational and irrational numbers, which is from pure arithmetic. So today we will start this chapter. Okay, so before discussing about this chapter, we need to know about the number system. Okay, so what is number system actually? So we all know that what is real number, what is rational number, what is irrational number, what is whole number, is not it? What is integers? We all know that. So now we will start from rational number. So what is rational number? So the definition of rational number is like that: any number that can be expressed in the form p by q, where p and q are both integers and q not equals to 0, is called a rational number. So rational numbers are always in the form of p by q. Okay, and here p and q both are integers. And the second condition is that the denominator is not equals to 0. That means q not equals to 0 means denominator is not equals to 0. Okay, so we know that if the denominator is 0, then ultimately the number will be not defined, is not it? So that so if q equals to 0, then ultimately the total number, that means p by 0, is not a rational number. We know that it is not defined, is not it? So the second condition is that q not equals to 0. Clear? So if we consider this number 5, so we can write 5 like 5 by 1, is not it? So if we write 5 like 5 by 1, then it is in the p by q form. That means the numerator p is equals to 5 here, and the denominator is 1 here. So here denominator is equals to 1, so that we can say that 5 is a rational number. Here p by q, it is in the form of p by q, and q not equals to 0, because here the value of q is 1, is not it? In the same way, if we consider minus 7, so minus 7 we can write like minus 7 by 1, here p by q form, and q not equals to 0. So this is also a rational number. And if we consider 0, 0 is also rational number. Why? We can write like 0 by 1 we can write 0 as 0 by 1. So we know that the q not equals to 0, that means q equals to 1 here, but the p is equals to 0 here, that means numerator is 0. But the condition of of a rational number is that q not equals to 0. So it satisfies this condition, is not it? So that 0 is also a rational number. So we can conclude that every integer is also a rational number. Clear? Now suppose if we consider a rational number, like suppose half. So if we multiply both the numerator and the denominator with 2, then we will get 2 by 4. And if we multiply both the 1 and 2 by 3, then we will get 3 by 6, is not it? And if we multiply both the numerator and denominator by other numbers, then also we will get a result, is not it? And we can say that 1 by 2 is equals to 2 by 4, and equals to 3 by 6 equals to 7 by 14, is not it? So all the numbers are in p by q form. Okay, and their value is ultimately same, is not it? So they are called equivalent rational numbers. Okay, that means in case of 2 by 4 or 3 by 6, they have a common factor other than 1, is not it? So we can say that they are equivalent to half, is not it? So we can say that these rational numbers are equivalent to the rational number half. Okay, thus we can choose half to represent all the numbers of the like 2 by 4, 3 by 6. We can choose half to represent 2 by 4 as well as 3 by 6, is not it? Okay, so now we can say that in case of rational numbers, the numerator and the denominator are co-prime. Okay, that means they have no common factor other than 1. Okay, so we can say that a rational number can be uniquely expressed as p by q, where p and q are both integers and q not equals to 0, and p and q have no common factors except 1. So that means p and q ultimately are co-prime. Okay, can we say that the reciprocal of 0 is a rational number? Can we say that? No. Why? Because the division by 0 is not allowed. So we can write the reciprocal of 0, that means we can write 0 like 0 by 1. So the reciprocal of 0 will be 1 by 0, and we know that any number divided by 0 is not defined, so that we cannot say that 0 is the reciprocal of 0 is also a rational number. We can't say that. Okay. Now when we write a rational number in the form of p by q, or q belongs to p and q both belongs to I, and that means integer, and q not equals to 0, usually we take q greater than 0 and p may be positive or negative. Okay, so suppose minus 7 by 5, here q greater than 0 and minus 7, that means p is negative here, and we can say that 7 by 5 is also a rational number, so here p is positive, is not it? Okay, so now we will discuss about representation of rational numbers on number line actually. So we all know that how to draw a number line, is not it? So that means we need to draw a line of suitable length. Okay, and nearly at the middle of this line we need to mark a point O that represents the number 0, is not it? And after that, starting from 0, we need to mark points on the line at equal distances, both on right as well as on the left side of O, is not it? And this point, suppose this point A, and another point B, okay, C, D, these points in the on the right hand side, okay, and we need to and again mark points in the left hand side like A prime, B prime, C prime, D prime, and if we mark this point like OA equals to AB, suppose this OA and the distance between A and B, okay, they are same, that means OA equals to AB, and the distance between AB and BC are same, so AB equals to BC. If we draw like that, and then we can say that this OA represents 1 unit actually. Okay, OA, the length OA represents 1 unit, so we can say that the point A indicates the number 1 and the point B indicates the number 2, as well as in the left side the A prime represents -1 and the B prime represents -2, is not it? Okay, so now suppose if we need to represent, suppose -3 by 2, suppose, or -3 by 2 on a number line, so how to represent -3 by 2 on a number line? Since the denominator of -3 by 2 is 2, is not it? So we need to divide each of OA or OAB, that means the unit lengths, okay, into 2 equal parts. Okay, and then to represent -3 by 2, we need to move 3 steps towards the left side of O to reach the point -3 by 2. Okay, so suppose this point represents O, and OA prime represents, that means A prime represents -1, and A prime B prime, that means this unit length, and the B prime represents -2. Then if we that means divide each of OA prime and A prime B prime, okay, into 2 equal parts, then we will get this type of number line, is not it? And then if we move 3 steps towards the left side of O, then we will get the point here, is not it? And this point represents -3 by 2. Okay, now if we want to represent, suppose 4 by 3, then that means the denominator is 3, is not it? So we need to divide all the unit lengths, that means OA, AB, okay, into 3 equal parts. Okay, and then we need to move 4 steps towards the right hand side of the O to reach the point 4 by 3, because 4 by 3 is positive, so we need to move 4 steps towards the right hand side, is not it, of the point O. Clear? So thus we can represent the rational numbers on number line. Okay, so now we will discuss about properties of rational number. So the properties are, suppose in the number 1, if A and B are any 2 rational numbers, then A plus B is also a rational number. So the addition of 2 rational number is always a rational number. So suppose if we consider 1 by 3 and 2 by 7 are 2 rational numbers, then they are after adding them we will get 13 by 21. This is also a rational number. Okay, and the subtraction is also the subtraction of one rational number from another rational number also gives a rational number. Suppose if we consider 1 by 3 and 2 by 7, if we subtract 2 by 7 from 1 by 3, then we will get 1 by 21. This is also a rational number. and the multiplication of two rational number also gives a rational number. 1 by 3 into 2 by 7 will give 2 by 21, and the division also gives a rational number. Okay, where the that means if we consider a and b are two rational numbers, then a by b is also a rational number. So if we divide 1 by 3 by 2 by 7, then we will get the 7 by 6 as result, and this is also a rational number. But here the condition is, suppose if we divide a rational number by 0, then we will get that means 0 ultimately, sorry, if we divide a rational number by 0, then it is not defined. So we need to multiply, we need to divide one rational number with another rational number, but the condition is that the denominator is not equals to 0. That means the rational number by which we will divide another rational number, this is not equals to 0. Clear? Another important thing is that if a and b are two rational numbers, then a plus b by 2 is a rational number and it lies between them. Okay, so if we consider, suppose if b greater than a, then a plus b by 2 is greater than b, but it is less than a. Okay, so if we consider two rational number a and b, and there and the a plus b by 2 will be a rational number which lies between them. Okay, now we will solve the examples. So the first example is that insert one rational number between 5 by 7 and 4 by 9 and arrange in ascending order. Okay, so we know that one rational number is 5 by 7 and 4 by 9. We need to insert one rational number between them. So if we divide the sum of these two rational number by 2, then we will get the rational number which is in between 5 by 7 and 4 by 9, isn't it? So 5 by 7 plus 4 by 9 by 2 will be the rational number. So after calculating this, we will get a rational number which is in between 5 by 7 and 4 by 9. And in another way we can solve it. How? So at first we need to take the LCM of the denominators of the rational numbers. So the denominator, LCM of denominators, that means 7 and 9 is 63, is not it? Now we need to multiply both the so now if we that means multiply the denominator of the first rational number with 9, then we will get the LCM 63, is not it? And in the same way, to maintain the equality, we need to also multiply the numerator of the number with 9, is not it? And the 9 will cancel out each other, though ultimately the number is 5 by 7. So 45 by 63 and 5 by 7 are equivalent rational numbers. So we in case of 5 by 7, we need to multiply both the denominators and numerators by 9. Okay, and in case of second rational number, that is 4 by 9, if we multiply the 9 with 7, then we will get 63, and to maintain the equality we need to also multiply the numerator with 7. So 4 into 7 by 9 into 7, that means 28 by 63. Okay, now we can say that 45 is greater than 28, is not it? So 5 by 7 is greater than 4 by 7, 4 by 9, we can say that. And the rational number between 4 by 9 and 5 by 7 is 4 by 9 plus 5 by 7 by 2. So this is 73 by 126. So as the 5 by 7 is greater than 4 by 9, then 73 by 126 is also greater than 4 by 9, but it is less than 5 by 7, is not it? Because it is in between 5 by 7 and 4 by 9. So in ascending order, we can arrange them like 4 by 9, then 73 by 126 and 5 by 7. Okay, that means 5 by 7 is greater than 73 by 126 is greater than 4 by 9. Now insert three rational numbers between 3 and 3.5. In the same way we can solve that, is not it? So the example 4, find 6 rational numbers between 3 by 5 and 4 by 5. So there is another method of finding large number of rational numbers between two given rational numbers. Okay, so how we can find a large number of rational numbers between two rational numbers? So at first we need to take the LCM of the denominators. Okay, so here the numbers are 3 by 5 and 4 by 5. So the denominators are 5 and 5. So that means the LCM is also 5. So here the denominators of each of the rational number is equals to its LCM, is not it? So then we need to find 6 rational numbers, is not it? So we need to multiply both the numerators and denominators of the two rational numbers with 6 plus 1, that means 7. So here we will get 3 into 7 by 5 into 7, that means 21 by 35, and 4 into 7 by 5 into 7, that means 28 by 35. So we know that 28 is greater than 21. So the numbers in between 21 and 28 is 22, 23, 24, 25, 26, 27. They are the numbers between 28 and 21, is not it? So we can say that 21 by 22 by 35, 23 by 35, 24 by 35, 25 by 35, 26 by 35 and 27 by 35 are rational numbers in between 28 by 35 and 21 by 35, is not it? So the rational numbers between 3 by 5 and 4 by 5 are 22 by 35, 23 by 35, 24 by 35 and 25 by 35 means 5 by 7, and then 26 by 35 and 27 by 35. So how we can find a large number of rational numbers between two rational numbers? At first we need to take the LCM of the rational numbers, and then we need to make the denominators of the two rational numbers equals to the LCM. Okay, after that we need to multiply both the numerators and the denominators of the rational numbers by one more than the number of required rational numbers. Okay, and after that we will get the rational numbers in between the two rational numbers. So